Good morning, everyone. I'm Yochana, and I'm here today to explain our project called Real Time Communication for Specially Able done through AI. The purpose of this project is that to try to help people who are deaf and dumb to communicate. Generally, the deaf and dumb people use American Sign Language, which is a standard to communicate, and most of the common people they do not know the sign language. So, this is our way to translate the sign language into normal standard English alphabet, and also to help normal people, that is the common people, to learn the sign language. So that what we have done, we have trained the AI model locally and on the IBM cloud. We have chosen the IBM cloud because it has a great service of Watson AI. Now, getting on to the explanation, uh, first I have imported the libraries which are necessary, and then using data image and data generator. Here we have 15,750 images belonging to 9 classes and 2,250 images belonging to another class. Like we have split the dataset into training dataset and the test dataset. Each class folders are to A to I, and each have given an integer index. And later we have created the model using sequential, and then we added layers such as input layers, and then we flattened the model, and then we had added hidden layers using railway activation function, and then we added output layers. Then we moved on to compiling, and then after compiling we have saved the model. We have trained the compiled the model up to 10 approaches, and the accuracy is 0.97, and then we saved the model. Next, moving on to the testing. First, we have imported the necessary libraries, and then we took an image of T, and we converted the image into data, and then we expanded the dimension into 4, and then we converted it respect to alphabet, now D, and then we went to OpenCV and then CNN video. As I have said before, we have trained the model in IBM Cloud, and first we have trained the IBM Cloud, trained the model in IBM Cloud using the Watson Studio and uploaded the Jupyter file, and we have installed the TensorFlow application version which works perfectly. And then we uploaded the data zip, and then we used the IBM cloud storage to access, and we used the API key so that we can access and we can save the streaming body so that we can extract it later. In this code, we have shown how to unzip the data set. Then we have installed the machine learning packages, and we have saved the model, and we after saving the model we have gotten the model ID. Using this model ID we have saved the machine learning model in our local repository. Designed a web application with default path which shows our template for easily making, and it is easily accessible to people. It is easily accessible to people. In this template we have provided the reference to the model which we have saved before. That is here. So, coming to the explanation of how we are getting the output, we generate the video feed as a sequence of image, and then we return a response to the Flask web server, and it displays the video as per frame after being operated by the OpenCV code which we have seen previously. Basically, here we create a frame, we take a region of interest from that frame, and we predict what is showed in that frame based on the model we have loaded. Either we can use either the locally trained model or IBM trained model. And getting on to the demonstration, that here is the region of interest. See, it has predicted C. Here it is predicted F. Even though there is a lag in the recognizing of the letters, the model was pretty accurate to identify the letters. Due to the problem in the dataset efficiency, we are unable to find it pretty accurate. If we train the model with greater approach, the accuracy will increase, so the prediction rate will be increased. So that's it. Thank you.